Why not? How do you know there are no more than 3?
Because it was, so the caveats are very weak, but so at the LEP collider at CERN, throughout the 1980s, 1990s, that machine was, well, it was built in the 80s, it was run through the 90s. And
did you have a position at CERN for a while?
Yeah. So I worked on as we're building the LHC, I worked on some ideas for little detectors close to the beams and so on the Atlas experiment. Before that, there was an electron-positron collider there called LEP, which was in the same tunnel. And that was really a factory to make things called Z-bosons, or Z-bosons, as I call them. And they're to do with one of the forces of nature, the weak force. And by measuring exactly the what's called the lifetime, the behavior, let's say, of that particle, you can see how many things it can decay into. How many, because basically the general rule in particle physics is if you're very massive and you can fall to bits into lighter things, then you will. And the more chance there is, the more things you can fall to bits into, the more rapidly you fall to bits, right, basically. So you can measure how many particles this thing can decay into. And so with some caveats about other generations, as we call them, being extremely heavy, and you wouldn't see them, then you can see how many different kinds of particle this thing can fall into. So it's a very famous measurement. So we're sure that there are these three copies.
3 and only 3.